And if I could give some context to that, since we're on that subject, very, very important subject, which what we do know from studies is that you could be born, I mean, vaginally, do everything right. Maybe you didn't have antibiotics and you're plant-based from birth and you're eating tons of plants and diversity, all the probiotics. You could do everything right, but there are studies to show, we know this, there are transgenerational effects. So you are not just getting your own microbiome. Your microbiome is an inheritance. We can think of it like that. And just like some of us are very blessed with an inheritance, many of us are like, wow, I come from a very wealthy family. Others, and there's a whole spectrum, right? The very wealthy to I received nothing from my parents, right? Or I didn't have that inheritance. The same is true for the microbiome, right? If your mother had IBS or Crohn's or other GI issues, you are more likely to have that because your mother is giving you her microbiome. And the same is true for your grandmother, your great grandmother, and the lineage continues, right? So you could do everything right, but that transgenerational effect is there. We even know this happens via the microbiome from pesticide exposure. So we had a whole generation of DDT is good for me. And then you go to the following generation where we're seeing now a rise in IBD, IBS, and now colon cancer. And we're like, what the heck's going on? Well, we had that transgenerational effect on top of, I mean, those of us born in the 80s and 90s, I mean, antibiotics were just given out like Pez candy, right? I mean, it was just what you did at the doctor's office. So you have to understand that context, like that does have ripple effects. So it's important if you're feeling like I'm doing everything right, but you're having those symptoms, just like what Delia said, you're having those symptoms, you're not feeling quite right, something's off. It makes sense to get it thoroughly checked, right? That's when it truly does make sense, and you should definitely do that and not just kind of guess and or not just rely on the fact like, but I'm doing everything right, so I couldn't have anything possibly wrong with me. It's like, we have to humble ourselves a little bit and be like, it's better to just, make sure or connect with someone who knows what they're doing to conservatively check and not just kind of throw, because there is that opposite where you can see a functional doctor and they throw everything at you and you're just even more overwhelmed. But
And I always say, because like I said, we worked in a gastroenterology office with a
Mhm.
plant-based gastroenterologist. So, people would always come to us and say, I don't want to get a colonoscopy, and I'm plant-based. I should be good. I'm eating the fiber. And it's
Yeah,
asking like, have you always been plant-based? If you were on a standard American diet for 40 years and you've been plant-based for 3 years, that's not always enough to undo what could have been there.
everything.
So, for that reason, I think that it is just important to guess, not guess, but check, test and not guess. I know Dr. Khan's a big fan of test, not guess as well. And, in our field, we are huge proponents of that.
So, obviously, when we're born with our DNA and our bodies proceed from there, but the bacteria is outside of our DNA, right? How do we end up with our microbiome then?
Mm.
Well, yeah. So, I mean, so there's evidence now. There's some really cool studies to show that there is some intracellular microbial activity, which is really cool. For the most part, I think we're gonna find out in studies that we think of newborn babies as these sterile new specimens, and
Mhm.
that's not really the case. Just like we're seeing, oh, there's viruses in the placenta. Oops, we were telling everyone there wasn't, and so I think it's one of those things like what it was like lack of evidence is not evidence of lack, right? And I think we're slowly finding out like, oh, these babies aren't quite as sterile as we thought, right? So it's like, first and foremost, I think our microbiome is always there. That's at least I would say my thesis and understanding of it right now. So really the mom is just enhancing that, almost kind of like as a preemptive or precursor to be like, welcome to the world. Now you're fully
Mhm.
in this microbial rich world, right? So I think yeah, to answer your question in a short way, I think it's always there and it's just enhanced by what we do. So a really cool area of research is called the exposome. That is called the exposome, what you're saying, which is now our outside exposure and how that's affecting what's already inside of us. That is the exposome research, where it's everything. Who's your roommate? Who's your spouse? What are you eating, drinking, exposed to? you name it, that is the exposome.
And then we also have nutrigenomics, where what we eat is going
Yeah.
to interact with our microbes and build that microbiome. But there's very strong data to support the first 1,000 days of life for really kind of setting the foundation for what's going on in our gut. And that is including in utero. So when our moms are pregnant with us, they can influence our gut microbiome. If your mother has inflammatory bowel disease, irritable bowel syndrome, very inflamed microbiome, that will kind of also pass on to the baby. But then we know that from delivery, right, whether you're birthed vaginally or via C-section, that will influence your microbiome one way or the other. If you're breastfed or formula fed, if you had colic or not, that will influence your microbiome. If you had allergies or intolerances, right, there are a lot of babies with, even though they're born with the enzymes to break down lactose intolerance from the very beginning. So from, conception, that baby's microbiome is really starting to lay its foundation.
But ultimately, even in vitro, would that microbiome be coming from the mother, just from inside the body before they pass through the vaginal canal, before they receive the colostrum from the mother during breastfeeding? But it
Yeah.
ultimately comes from the mother.
We do
Ultimately.
see absolutely that contributes quite a bit to the microbiome. There's other things that will impact it, but mom's microbiome can also communicate and kind of send the very first signals to that baby's developing microbiome, especially in the last few months of pregnancy when the microbiome is really emerging.
But what's funny where it gets complex is there's studies to go. So for example, let's say mom came from a very healthy family. But mom meets an unhealthy partner who, right? So mom's family was eating organic and grew up on a farm, a regenerative organic farm or whatever. And she meets a partner from the city who eats hot dogs and, processed food. And so we do know who you live with, who you cohabitate with. Even in a relatively short amount of time, your microbiome will start to resemble who you're cohabitating with more than your own family. So so it's very interesting that it also, that's where the male counterpart is having an effect where their microbiome and the environment that they maybe take mom into or move mom into has a big effect. So yes, mom is creating the baby's microbiome, but where they are, who they're with also has that effect as well. And we've seen that in studies. So it's quite complex. Yeah, many, many dominoes and moving parts for sure.
Yeah, as we go along, I'm just like writing down questions, and it's, to use your river analogy, it's like I'm like, do I go down this part? There's just so much.
Yeah, which pathway are you choosing?
And I think, even, still for a lot of people, it's still a relatively new subject. So I'm trying to get to the heart of things, like with regard to breastfeeding and the colostrum. And my understanding is, with breastfeeding, that milk has a large constituent of a disaccharide that's undigestible from by the baby, and it's
Mhm.
figure out why is the milk made up of so much material that the baby can't digest. Can you talk about that?
HMOs, so
Yeah.
human milk oligosaccharides is a fairly like newer finding of like, whoa, what are these HMOs? And we're not talking about insurance HMO. It's human milk oligosaccharides. These are these special polysaccharides that are
Carbohydrate chains.
carbohydrate chains that are not digested. And you're like, well, isn't that going to hurt the baby? Or like, what's going on? And it's like, guess who's eating those? The baby's microbiome, right? You're essentially it's essentially like feed them and they will come, right? You're like getting a party ready, right? And you're setting everything up, putting out all the food, and you're like, all right, microbes, come and eat, right? And so you're getting that in breast milk. And what's even cooler with breast milk is over time, and as humans, for the most part, we understand that anthropologically we can breastfeed up to the age of 5, and some cultures we see this in more like third world where there's more scarcity. Babies, if possible, can breastfeed up to 6. We've seen that on an average from the last several hundred years. So it's really interesting to see that because breast milk will change over time as the baby develops. And just another cool thing with breastfeeding is as the baby is feeding, the mother's nipple is analyzing baby's saliva. And it's taking baby's DNA, analyzing what's going on in the baby to then alter the milk if necessary. So it's
Create more immunoglobulins, support baby's
insane.
immune system. But yeah, with those HMOs, we know not only are they increasing populations and richness of the microbes in the gut, they also have been shown in studies to help with the gut barrier. So that helps to strengthen babies' developing gut barrier, make it more strong. That will decrease babies' risk of allergies and food intolerances. They have been shown to be beneficial for brain development. They can bind to pathogens, so they can help protect baby from them. So these human milk oligosaccharides are so incredible, so important. I think they're trying to mimic them in formula, but we're seeing that they are functioning in not exactly the same way. So if someone's able to breastfeed, breastfeeding is so important, especially in those first 1,000 days of life. So about the first 2 years of the baby's life.
And while antibiotics was a major discovery that saved so many lives, can you talk about the negative impact for the way that we use antibiotics today on the microbiome?
Absolutely. So we are finding that it can take up to 3 months to really recover the microbiome after one single course of antibiotics. And for some people, that can even take longer. And so they're not just targeting that one bug, that one pathogen, that one bacteria that is maybe causing problems and causing symptoms. They're going to even target the healthy helpers. They're going to target everyone. So there are so many diseases and so many conditions that have been associated to antibiotic, especially antibiotic overuse. So we see rates of inflammatory bowel disease increase with that. That's one of the major contributing factors for developing inflammatory bowel disease. Also irritable bowel syndrome. Again, allergies we see increase with antibiotic use. We do tend to see also a link with just all those other diseases that kind of flourish out from the gut because it is causing that imbalance. So with antibiotics, it's always asking, do I absolutely need this? What will happen if I don't take this antibiotic? What's an alternative? Especially if it's for something localized. For example, if you have a sinus infection, you can ask, is there some type of wash that I can use that I can rinse my sinus cavity with rather than taking an oral broad spectrum antibiotic that will affect me from tip to toe? If it's something topical, asking, can I use a topical antimicrobial instead of orally ingesting something that's going to offset my gut microbiome? So we are seeing such increased disease risk with antibiotic overuse. And it's not just what we're consuming ourselves or what we're consenting to take. We do know we've tested certain things like our waterways, and sometimes water is contaminated with antibiotics because people will do things like flush their antibiotics down the toilet or from animal runoff. Animal products are a huge source of antibiotics for people as well. So if you're consuming animal products, you could be consuming the antibiotics that those animals were fed. Animal agriculture is the #1 consumer of antibiotics in our country as well. So it's really important for people to understand, even if you don't take antibiotics, you're probably interacting with them in some way, shape, or
Yeah, if
form.
I could just say, yeah, the multi-billion-dollar annually antibiotic just in the US use, 80% of that is going to livestock. So everyone's eating Chick-fil-A, or especially, if you're getting that livestock through a fast food drive-through, you are likely getting the most antibiotic-rich meat that you can get, because that's where most of our antibiotics are going to, creating antibiotic-resistant microbes, which then require more antibiotics if you do acquire an antibiotic